today, although this is called a probability revision class, but this is not exactly a class of probability, and I'll explain why, or you will find out in the due course of the session as to why this is not exactly probability revision. But because this class is called a revision to probability, let's do a quick recap of what is probability. I think everyone understands that what is the meaning of probability. So when we calculate probability, then probability is always a ratio, right? Ratio of number of ways in which an event can happen favorably divided by the total number of ways that that particular event can happen. So basically, if I want to find out the probability of a specific type of an outcome of an event, then the number of ways in which that specific outcome can happen divided by the total number of outcomes that are possible for that event will always give me probability. And this is, I think, something that should be absolutely clear to all of us. And we also know that probability will always lie between 0 and 1, right? Or I'll just put equal to here. An absolutely impossible event's probability will be 0 and an absolutely certain event's probability will be 1. So this is what is basically division of probability. There's nothing more to probability. If we understand these things, we should be able to calculate probability of anything and everything. Okay. Now, before we look at the questions of this particular sheet, which I, of course, want to discuss one by one, let me give you a different question which is not present in the sheet to start off this class. Let's say that there is a batch of students in a college. Okay. Now, in that batch, the number of boys, or in that batch, 80% of the students are boys, and the remaining are girls. The remaining 20% are girls, suppose. Okay. Now, an exam is being conducted. Okay. And in that exam, the percentage of boys who are passing, pass percentage of boys, let's say, is equal to 40%. And pass percentage of girls, the percentage of girls who are passing, let's say, is 60%. Okay. This is a question which is given. I hope everyone is clear with the question that in the college, in the batch of the college, there are 80% students are boys, 20% of the students are girls. And a particular exam is being conducted. In that exam, 40% of the boys are passing, 60% of the girls are passing. Okay. Now, question is that you are randomly selecting a student. What is the probability that that student has passed the examination? Okay, suppose this is what we have to calculate. That I'm selecting a student at random and I have to find out the probability that that student has passed. Now tell me, how will you approach the question? I don't want the answer. You tell me, how will you approach the question? What's the first thing that you will do? How will you start the solution of this question? Okay, Manav, sure, we can do that, but Sylvie, that is the answer that is getting. Sylvie, can you type out that particular response in public? You don't have to consider the total. You can just type out the first part of that chat in public chat for everyone else to see. Okay, so I'm getting a lot of responses here. So a lot of you are right. Okay, so Aviral is saying take 4 cases. Tanuj is saying deal with boys first and girls separately. That is what I was looking for. Try to find all 4 ratio. Okay, Animesh. Aviral is saying take 4 cases, then 2 cases where the person is passing. All of you are in the right ballpark. Sylvie gave me the answer at the beginning. Then find the numbers in each case. So what Sylvie meant by each case is that I know that I have to find the probability that I've selected a student randomly who has passed. Okay, assume some total number of students. You actually don't even need to assume that because anyway we are dealing with, say, probability here. But what everyone is getting to here is that we have to make cases, right? Everyone understands that we have to make cases. So what can be the case of a random student passing? What can be the 2 cases, or only 2 cases, right, of a random student passing? What is the first case? Case 1. Case 1 is boy has passed. Absolutely right. That the randomly selected student is a boy and that boy has passed. And case 2 is the randomly selected student is a girl and that girl has passed. These are the only 2 ways in which I can get a student who has passed. So case 1, what is the probability that a randomly selected student who is a boy has passed? So tell me in terms of fractions, not in terms of the final answer. How will you calculate this? Type it in public chat for everyone else to see. That's absolutely right, Siddharth. Perfect. Right. So Siddharth has written, and I think everyone else will agree, 80 by 100 into 40 by 100. And case 2, I think everyone will agree. Absolutely right, Tanush. Perfect. Absolutely right, Sylvie. Case 2, everyone will agree that will be, sorry, 40, 20 by 100 into 60 by 100. Now observe what you're doing. Okay, this form of observation is very important in probability to make. Although some of you might have instinctively written this down, but observing what we have written, right? So first, when I'm saying that case 1, the boy has passed. Rajni, it will be the same thing. It doesn't matter much if you want to find failure. Either the randomly selected student is a boy and has failed, or the randomly selected student is a girl and has failed. It's the same thing. It is not going to change anything with respect to the solution. But let's observe this, what we have done. When we are taking case 1, then we are saying that the randomly selected student is a boy and he has passed. Right? Imagine the language in your head. What are we calculating here? We're calculating the probability that the randomly selected student is a boy and he has passed. Calculating something like this is called calculation of conditional probability. Might be a term that you might have heard of before, but it might have been very confusing when someone who has a very high degree of understanding of the topic of probability explains it, that what is the meaning of conditional probability. But very simply put, this is what is conditional probability. If you have been able to do this, you have done conditional probability. What is the conditional probability part here? So what the condition here is that I was trying to find out that the random student has passed. But you divided it into 2 cases, and in each case, you put a different condition on the student who has passed. So the first case, the condition is that the randomly selected student is a boy who has passed. Absolutely right, Gayatri. Given that the randomly selected student is a boy, he has passed. Second case's condition is that given the randomly selected student is a girl, she has passed. So I am putting a condition to create the case, and the condition is present here. That first case, the condition is that the randomly selected student is a boy. Second is if the randomly selected student is a girl. So this is something very important to understand in a very practical sense. Imagine, had I not given you this question, had I asked you in this set that what is the probability that a randomly selected student has passed if the student was a boy? Again, I'll repeat, just giving you this data, had I asked you, what is the probability that a randomly selected student has passed if that student is a boy? Then a lot of you would have told me the answer is 40 by 100, which is wrong. Because the question is phrased in such a way that the probability that we have to calculate, a condition is being put on it. So the conditions, if the question says that what is the probability that a randomly selected student has passed if the student is a boy, then answer will not be 40 by 100. Answer will be 80 by 100 into 40 by 100. Because I have to calculate the probability of the condition happening and then the probability of the outcome. This is what is conditional probability. I hope everyone is clear what happens in a conditional probability. I am to calculate the probability of something, but I'm putting a condition on it. So whenever a condition is being put on something, the probability of that condition also has to be taken into consideration. Only then are we calculating the answers correctly. Okay. I hope this part has got no confusion whatsoever. Now, why do we have to consider the probability of the condition? Because the condition happening has not been given to us as a certainty. It is like me saying that if you give 12 mock tests, then your chance of getting a 99 percentile becomes double. And if I ask you now, tell me what is the chance of you getting a 99 percentile? You might say that it is double of everyone else. You might say that. But before that, you will have to tell me that what is the probability that you will take 12 mock tests from here. Without saying that, if you just say that I'm going to double the probability of me getting a 99 percentile, I will not accept that answer because I do not know whether you will abide by the condition that I put on you that you have to take 12 more mock tests from here. So whenever the question asker is putting a condition on the probability that I have to calculate, I have to calculate the probability of the condition as well before I calculate the probability of the outcome. Okay, right. If this is clear, right, then let's move on to the sheet and let's look at question number 1. Also, I'm telling you that these are not the kind of questions that you will expect in any of the examinations, but I want to develop a sense of logical thinking with respect to probability questions, and I want to make a much larger point than mere probability through these questions. Okay. I hope everyone has read question number 1 and everyone has looked at statement A. Right, let me once again briefly explain what this question is. That there is a disease that is going around in the country. It's a very deadly disease, fatal disease. You contract it within 2 weeks, you're gone. Everyone who contracts the disease survives for a maximum of 2 weeks. And you wake up one morning and you find that you have the symptoms of that particular condition and you are scared. You go and take a test in a particular medical center and the test results are immediately available. It's a very rapid test. The results are immediately available. And you know, it has been lab certified that the test has 99% accuracy. Okay. So the disease is a rare disease. It only affects 1 among 1,000 people. And the test has got 99% accuracy. And you take the test and you see that it is positive, which means that you have tested positive for the disease. According to the test, you have that disease. Now, option A or the statement A says that, is it now a sensible decision to say your final goodbyes and write your will? So tell me, is that a sensible decision? Do you think that the test has said that you have the disease? Is that time for you to think that, okay, that's it, my time on earth is done and write the will or not? How many of you feel that the answer is yes? How many of you feel that the answer is no? Okay. So I'm getting a lot of yeses. Okay. You will count on the 1%. Okay, I'm getting a few no's. 1% chance being, people are clinging on to 1%. By the way, sensible definition I have given here at the end. Assume sensibility implies that there is more probability of your belief being true than not. So my belief is that I should write the will. So I should write the will means that the probability of me dying is more than 50%. If that is the case, then I should be writing my will. I should be saying my final goodbyes. So then how many yeses, how many no's? Majority are yeses. I'm still getting some no's. There is some for okay, Aryaka, but my question is that instinctively, I don't even want you to calculate. Understand the condition. You have taken the test and the test says that you have the disease. Does it make sense to prepare for a death? And sense is when you have got 50% or more likelihood of death. Okay. Okay, so I'm getting a lot of yeses, a few no's. Also because it's subjective question. No, it's not. I've given you all the objectivity. If it's more than 50% probability, then it makes sense. Okay, all actually no, but for the question, yes. Okay, so people are thinking very philosophically. All right. Let's mathematically try to figure this out. Okay. Now tell me, what do we know? What do we know for sure? We know for sure that the test is positive. Okay. Now I have to calculate the probability of the fact that I have the disease. Given that the test is positive. Again, listen to the statement that I'm telling you. I have to calculate the probability that I have the disease, given that the test is positive. Now, focus on the language that I'm using here. It is very similar to the language of the conditional probability question that I used before. What is the probability that the student has failed, given that the student is a boy? Similarly, what is the probability of you having the disease, given that you have tested positive? Okay. So then I have to calculate this as conditional probability. So given that the test is positive, how many cases are possible? How many cases are possible under which the test is positive? Absolutely right, Rishika. There are 2 tests which are possible, or 2 cases which are possible. Either I have the disease and I have tested positive, or I don't have the disease and I have tested positive. So it is a true positive, absolutely right, Shiba, or a false positive. So let's calculate. What is the probability of a true positive? That I have the disease and I have tested positive. What is the probability of this? Again, conditional probability, guys, not directly 99 by 100. You have to take the probability of the condition, then multiply it by the probability that I want to find out. Excellent answer, Muskan. Absolutely right. So, probability of me having the disease, because I am from a population where only 1 in 1,000 people contract the disease. So, 1 by 1,000 is the probability that I have the disease. And I have tested positive. This is the probability of it being a true positive. Or it can be a false positive. So in that case, I don't have the disease, which is 999 by 1,000. Because 999 people out of 1,000 people don't have the disease, into the fact that the test is false. Probability of the test being false, absolutely right, Muskan, is 1 by 100. So which means that if someone asks you, what is the total probability that you tested positive? Then tell me, what will I do to these two quantities? What is the total probability of someone testing positive or you testing positive for this disease? Absolutely right, Rishika. We will add them, right? Because either this or this can happen. Either 1 by 1000 into 99 by 100 or 999 by 1000 into 1 by 100, right? This is the total probability of the test being positive. Now, when will I take the decision of writing my will and saying the final goodbyes? When the first case is true. So what is the probability of the first case being true? Total probability in the denominator and favorable probability in the numerator. I hope you're getting my point. Probability is ratio of favorable by total. Total probability of the event that I know has happened. What has happened? I have tested positive. What's the probability of me testing positive? Either I have the disease and I've tested positive, or I don't have the disease and I've tested positive. This is the total probability of the test being positive. And the favorable probability, which in this case is sadly unfavorable, but I'm trying to find the probability of me dying, of me having the disease. So that will be the fact that I have the disease and I've tested positive, which is 1 by 1000 into 99 by 100. So that will be the numerator. Favorable by total. Can someone calculate and tell me approximately correct up to 2 decimal places? How much is this? Absolutely right, Manu. I'll wait for the others to calculate and let it be a revelation. Use a calculator if you have to. Don't have to do the calculation by hand. Also, don't take LCM. You can just take 1000 into 100 common from the numerator and denominator and cancel that off. Use a calculator, everyone. Sylvie, check calculation again. Some mistake. No, Rishika. 99% accuracy of the test, which means that 1% times it goes wrong. So it has gone wrong, when it is saying that I have the disease, but I don't have the disease. So it's 1 by 100. Absolutely right, Aryan. Absolutely right, Animesh. Give me the answer in decimal points. Yes, so that is in what terms? Absolutely right, Sylvie. Perfect. I'm getting a lot of right answers. Everyone is getting 0.09. 0.09 is what? Everyone? 9%. So many of you were ready to write your will and say your goodbyes for 9% probability that you are going to die. Do you realize how stupid of a choice and decision did you make? Because the question said that the test has 99% accuracy. You believed that test, but you forgot the rarity of the disease to be taken into consideration. And you did not understand how probability works. You looked at the percentage accuracy of the test and you thought that that is the probability that I have the disease, when it's not. You only have a 9% probability of the disease being contracted. You're always irrational towards life, and not always, but we shouldn't be irrational towards anything in this world. Okay. I hope this is clear. If this is clear, then you read statement B. Okay. So you are someone who is rational. You realize that 9% probability is not enough. I don't know whether this is the right result or not. So you take the test again. And again, you test positive. Now tell me, does it make sense to write your will? Again, remember that you need to have more probability that your belief is true than not, which means you have to get a more than 50% probability after the second test. Do you think a second test will give you a more than 50% probability? Without calculating. One test is giving you 9%. Two tests should. Siddharth, if you're saying no, Rajni is saying no. Two tests should give you how much probability? Think about it in a very instinctive fashion and tell me. Instinctively. Same probability as above case. Okay, you're saying that 9%. Rajni has squared it. Rajni is saying square of this. Okay, square of 0.09, Rajni, is not 0.81. It is 0.0081, by the way. Even lesser. Yes, Rishika is saying second test is also positive, means it is even less likely that you have the disease. That's a very funny way to say that. Okay, Aryaka also believes that. Siddharth has just multiplied this by 2. 9%, 18%. Okay, just multiply by 2. Okay, fine. Okay, let's see how that is calculated. Okay. Now it's the second test. Still not more than 50%. Okay, Tanuja also believes. A lot of you believe that still not more than 50%. Few of you are telling me definitely more than 50%. Okay. Or Manav also says definitely more. Let's see. Okay. So now this time We have 4 cases now. No, Aradhya, we don't have that many number of cases. I already know that first test, after the first test, I have done this calculation. Okay. Are in both cases independent of each other? You will think, Arimesh, but let me get to it. So again, this test can be positive, either as a true positive or as a false positive. So tell me, how will you calculate the true positive? True positive is you have the probability that you have the disease and you have tested positive. Tell me, what is the probability that you have the disease? At the time of the second test, what is the probability that you have the disease? Excellent answer, Aviral. No, Tanuj, not 1 by 1000. Absolutely right, Sylvie. The initial probability changes because I have already taken one test. Excellent answer, Arya. I've already taken one test and that has put the probability of me having the disease. I'm not dependent upon the sample size from which I've been taken anymore. I've already tested positive once, which means that I have 9% probability of having the disease. And the test is correct. Or I don't have the disease, which is 81 by 100. And the test has given me a wrong positive. And of course, numerator is I have the disease and I have tested positive. Absolutely right, Rishika. Now everyone calculate and tell me how much percentage is this? Sorry, 91. I'm so sorry. This is 91. My bad. Everyone calculate and tell me how much probability is it that you have the disease after the second test? Absolutely right, Sylvie. Or correct up to 2 decimal places? Very close, Manav. Absolutely right, Siddharth. Perfect. 0.91 or 91%. Does this amaze you? That one test being positive put your probability of having the disease at only 9%. A subsequent second test being positive put the probability of you having the disease at 91%. I hope you understand how weirdly and non-instinctively probability works. But it only works non-instinctively when you look at it from a very distant non-mathematical perspective. When you look at it in a very mathematical and rational perspective, you will realize that it is actually very instinctive. And it is because of this reason that people often make really bad decisions in their life, especially CAT aspirants. Do not understand how probability works and they make very bad decisions in their preparation, which is what mainly I wanted to talk about in this class. Before that, does anyone know what is this method that we have used to calculate these two probabilities called? It is a very famous theorem. Absolutely right, Rishika. Perfect. Absolutely right, Aviral. Absolutely right, Lakshman. This is what is the absolutely right, Nitin. The Bayes theorem of calculating probability. You know, Robert Bayes, very great mathematician from UK, he realized as a very matter of fact kind of a fashion that when we keep on observing the evidence for something, the probability of it becomes higher and higher. Yeah. And this is something that all of us subconsciously use. If you have a friend, right, whose lies have been caught twice or thrice, then fourth time, whatever that friend tells you, you don't believe it. At the same time, if your friend who has always been truthful to us, if they lie to you once, and then again they say something new the next day, you will still want to believe that friend because majority of the time your observation has been that they have told you the truth. So although they have lied to you once and you have been hurt by it, but then after that also you tend to trust them. Whereas a person who has lied to you 3 times consecutively, even if they're telling you the truth 4 times, you will not listen to them. And that is what is the Bayesian way of thinking. The more evidence we have, the higher the probability of our belief is. And this is what Bayes actually put into an equation. He said that when we are calculating the probability of a hypothesis being true, provided the evidence being true for it. Okay, let me explain these words. What's the meaning of hypothesis? A hypothesis is an inference that we draw based on observations. All of us have heard of Avogadro's hypothesis, right? So Avogadro said that 1 mole of a substance has got 6.023 into 10 to the power 23 molecules. Do you think Avogadro sat and counted how many molecules are there in one mole of a substance? Absolutely not. Avogadro, he looked at 1 mole of every single substance. He took 1 mole of every single substance, which is weight in grams equal to their molecular weight. And then based on some experiments and experimental evidence, he said that every mole of a substance will have 6.023 into 10 to the power 23 molecules. That's his hypothesis. Because he had evidence to prove that that number is accurate. Okay. So hypothesis is when we have evidence and we come up with our own theory that this is happening because of this reason. So probability of our hypothesis being true, given that we have observed an evidence, is equal to probability of the evidence being true, given the hypothesis is true, multiplied by probability of hypothesis. This might be a bit confusing to think about, but look at this here. This is probability of the evidence is being true, provided the hypothesis is true. The evidence is true, which means that test positive. Right? This is the evidence. And this is the probability of the hypothesis. Hypothesis is that I have the disease. Probability of I have the disease is 9 by 100. So that will be in the numerator divided by total probability of evidence. So evidence can be true when the hypothesis is true. Evidence can be true when the hypothesis is not true. So both these I will have to consider in the denominator. This is what is the Bayes theorem. So Bayes theorem should always be used. When looking at an evidence, you are being asked to calculate the probability of a hypothesis that the question is presenting in front of you. Okay. Is it true that during COVID, number of positive cases was irrelevant as compared to actual cases? It is, Animesh, because so many of the cases did not go tested. But that is, of course, not a Bayesian rule. It is just a rule of the samples, right? So that's why we take samples and we extrapolate it to the rest of the population. The actual numbers are nowhere close to reflection, or the observed cases are nowhere close to reflection of the actual cases. But anyway, coming back to the point, this theorem, Robert Bayes, after he wrote down this theorem, he crumpled up this piece of paper, put it inside his diary, and then kept it away for 20 years. Because he thought that this is a very, very natural human thing to know. Everyone will know this, that when I get more and more evidence, my hypothesis will become more and more true. And he died without even presenting this paper. After his death, his family was cleaning his desk and they found his diary with this crumpled piece of paper, and they gave it to the Royal Society of Mathematicians in UK, and then they decided to publish it as a paper. Yeah. But problem is that Bayes was wrong in the sense that he thought this is common knowledge when it absolutely is not. And you, a lot of you right now in the chat are a testament to this fact that people don't understand the Bayes theorem. I can't tell you the number of times that people have told me that, sir, I think I'm weak at LRDA. I asked them, so why are you saying that? They say that, sir, last 2 mocks, I could not even solve a single set. Then I've got people who come and tell me that, sir, the approach that you recommended did not work for me. I don't think it will work for me. I will try something different. I ask them why, because they say that I tried it in the last mock and I scored the same that I was scoring before. Now, the problem with both these statements is that you do not have enough evidence to come up with the hypothesis. Your evidence is of 1 mock test or 2 mock tests. And based on that, you are confidently spouting a hypothesis. And the probability of that hypothesis might be as low or even lower than this 9% that we wrote down first. We refuse to wait for hypothesis several different times just because it is going to fit our narrative. So many times people will tell me that, sir, the 2 runs of the quant section is not working on. So last mock of LRDA has gone completely bad, sir. I think I have lost it. I think I've forgotten how to do LRDA. I have to again practice LRDA. So I'm going to sacrifice on VRC and I'm going to sacrifice on quant. Why? Because one single evidence is making you believe that a drastic sense of a hypothesis is true. So what I want you to remember while you're preparing for the CAT examination from here on, because from here on you're going to be taking a lot of mock tests, is that do not jump to conclusions and hypotheses based on evidence from singular mock tests or singular observations or singular evidences. That is one side of it. That try to understand the Bayesian model of thinking. On the other side of it, there are people who accept the fact that you need multiple evidences, and then they have multiple different evidences of something is not going right for them. Right? So I know people who will consistently get a certain topic of reading comprehension exercises wrong. So they will get, say, all philosophy-based passages questions incorrect multiple times across 3, 4, 5 marks, right? So then according to Bayesian probability, there is some kind of a problem. Now, when there is a problem, what do you change? You tell me, when I calculate the probability of my hypothesis and the hypothesis that there is something wrong with my preparation, okay, that there is something wrong with the preparation because of which I'm not being able to understand and grasp the meaning of philosophical passages well enough to answer questions correctly, then what should I change? Among hypothesis, evidence, what should I change? Anyone? How do I get a better score? Absolutely right, Siddharth. Change the approach. Change the evidence. How do I change the evidence? Absolutely right, Ashika. I change the evidence by changing my experiment, right? I need to do something different in order to get to a different outcome. People do not understand this as well. Because I have seen people, when they find that they are not getting scores in philosophical RCs, their first instinct is that, sir, I don't understand philosophy. I don't think that if in the CAT paper, if there's a philosophy passage, I will not attempt it. Now, what they are doing is that they are not changing their approach. They are blaming their entire problem on an external source. And this is not just with respect to reading comprehension exercises or LRDA or quant. I have seen people, without taking names, I have had students tell me things like, sir, can you explain this to me? I could not understand in the video. Then when I say the same thing in the recorded video again to them, they said, no, now I can understand. I did not understand before because the video was too fast. Okay. Now, when you are constantly trying to pin your shortcomings as reasons on something external that you can't affect, then you might as well be resigned to the probability of the hypothesis being high, that you are bad or there's a problem with you. The only way to change a bad hypothesis probability is to change something within yourself. And this is not just with respect to the CAT examination, this is with respect to life. I know people who will come and tell me that, sir, I did not have a reading habit from my childhood. That's why I'm not doing well in reading comprehension. Sir, I did not take math in 11th and 12th. That's why I will not be able to score well in quant. Sir, my teachers during my school life had completely spoiled my habit. That's why I'm not being able to leave questions. Very easy to put the reasons for our shortcomings on things that we cannot affect. And if we cannot change something, then of course the probability is not going to change. If I need to change the probability, I need to take charge of my life. And this is going to be true for every single sphere of your life. And this kind of a Gyan related session is what I wanted to give you through this particular session of Bayes Theorem. I hope all of you will start analyzing your performances a bit better and coming up with better hypothesis using stronger evidence. And once you have enough evidence to believe your hypothesis, then you take the mantle, the responsibility on your own shoulders to change something, to improve. That is the only way forward in life in general, but specifically in the last 1.5 months to CAT. All of you can improve from here, provided you change something within yourself. Now, if I've driven this point home, then one more question I will solve, question 3 and 4, you can solve after that. Okay. I don't think I need to explain anything about 3 and 4, but 2, let's move on to question number 2. I hope all of you have read this question as well. We are going to solve 2 to have some fun. Okay. Now, without calculating anything, right? Understand the situation. Let me explain the situation once again. You have got 3 cards in a hat. Okay. One card has got both sides red. One card has got both sides black. One card has one side red and one side black. And otherwise, in shape and size, all 3 cards are absolutely identical. Only the color of the faces is different. Now, you are to randomly select a card blindfolded from the hat. And after selection, if you predict which card you have selected correctly, then you get $1 million. Okay. Situation 1 is that you select one randomly, you place it on the table, and you're saying that this is the card which has got one side red and one side black. Situation 2 is that you have selected one card on random, placed it on the table, and your blindfold slips a bit. And through one eye, you can momentarily, for 1 second, you look at the card and you find that the top face, the face that you can see, is actually red in color. After that, you predict that this card is red and black. Now tell me, in which of these 2 situations, instinctively, do you have a higher probability of ending up as a millionaire? In situation 1 or in situation 2? Instinctively, what does common sense tell you? Okay, all right. Okay, majority are saying 2. I've got 1. Okay, Varun says 50% chance in the second. Okay, okay, I'm getting a few answers which are correct. Let me tell you, everyone who said 2, situation 2, maybe they are right. Okay, let's calculate. First situation 1. Tell me what is the probability that the card that you've selected is one side red and one side black. This should be very, very simple. Does not require any kind of calculation. So everyone will agree with this, right? This is 1/3. All right, Sridhar. Okay. Let's take situation 2 now. Let's try to calculate situation 2. And we will use the Bayesian method to calculate the probability that the card that is present on the table is one side black and one side red. So for that, you tell me, what evidence do you have? What evidence have you gathered in situation 2? That one side is red, absolutely red. When can one side be red? In which cases can one side be red? In 2 cases, absolutely red. 2 out of 3 cases. Either it is a card in which both faces are red, or it is a card in which one face is red and one face is black. So let's calculate the total probability of us looking at the card and seeing one red. So it is possible that the card is the card in which both faces are red. So the probability of the card being both faces are red is 1/3. And the probability that one of the faces that I'm looking at in that card is red is how much? Sylvie, think and tell me. I have picked the card in which both sides are red. Okay, so probability of the card being both sides red is 1/3. Tanuj, Siddharth, think and tell me. What is the probability that the face that is facing me is red in that card? Absolutely right, Rishikant. No, Dhanush, think again. No, Gayatri, absolutely right, Divya. Rajni, where are we getting 4 from? Absolutely right, Vishwesh. Absolutely right, Aryan. 1. Because there's a condition on the probability. The condition is that I have selected that card in which both sides are red. So both sides are red. So probability of the side which is facing me, the face which is facing me is red, is 1 because either of the faces facing me will be red. So 1/3 into 1 is the case where the condition is that I have selected the card in which both faces are red. Or I could have selected. Yes, Shubham, it is confirmed. I am calculating conditional probability. Are you listening to me? Again, I'll repeat. The evidence is that one side is red or the face which is facing me is red. In how many cases can that happen? It can happen in 2 cases. Either I have selected that card in which both faces are red, or I have selected the card in which one face is red and one face is black. I'm taking the first condition of selecting the card in which both faces are red, which is 1/3, multiplied by the probability that one of the faces which is facing me is red. So the probability of one of the faces facing me red and that card in which both faces are red is 1. It's absolute certainty. Or, right, Shivam? I hope that is clear. Or I have selected the card in which one face is red and one face is black, and the red face is facing me. What's the probability of that? Absolutely right. Now it is 1/2. And the favorable probability is when it is a red and black card. Now calculator, tell me how much is this? Calculate and tell me how much is this. Absolutely right. Simplify this. See what a beautiful answer. The answer is still 1/3. Despite me having extra information. Divya, it's the same thing that we discussed for the Bayes theorem. Total probability of the evidence being true. The evidence is that the face of the card which is facing me is red, which means one face of the card is red. Probability of one face of the card being red is either I've selected the 2 red-faced card and the face which is facing me is red, or I have selected the red and black card and the face which is facing me is red. So the probability in both the cases, whether I made that observation, whether my blindfold slipped or not, did not matter. In both the cases, I have only 1/3 probability of winning $1 million if I decided that, or if I predicted that it is a red and black card. Now tell me situation 2, after making that observation that one side is red, What should I have done to increase my probability of becoming a millionaire? Absolutely right, Arvind. If I had looked at the card which is facing me is red, and if I knew Bayes theorem, I should have predicted that the card, absolutely right, Rajni, has got both faces red. Instinctively, it doesn't make sense. Mathematically, it does. This brings me to my second point inside the CAT examination. You know, you will, as CAT gets nearer, you will find several people giving you all these tips and tricks, especially on YouTube channels and social media and Quora answers, that this kind of a question, this will be the answer. If you see four options, then you mark that option which is of the middle value. You mark that option which is of highest value. If this number is there, that number will be the answer. Start the paper from the middle of the quant section. That is where the simple questions will be. Geometry question, if there's a figure given, you don't have to do the calculation. Instinctively, estimated measurement, you look at whether it's near the midpoint or not, and then mark a measurement which is half of the value of the length which is given. And all of this or none of this will actually work. None of this will work at all because CAT paper cannot be solved using instinct. Especially, I guarantee the quant section of the CAT paper, considering IIM Calcutta is setting it this year, none of the questions can be solved instinctively. Don't rely on instinct. Calculate, follow the processes properly to the T, get to the correct answer, then mark the answer. Absolutely right, Rupakeshwar. This is absolutely similar to the Monty Hall problem, and there's a huge controversy with this. But Bayesian probability still says that 1 by 3, 1 by 3. Right? We will discuss Monty Hall problem separately for everyone who doesn't know. I love discussing the Monty Hall problem. We might do that in a separate session, but that's not for today. But the point that I'm trying to make here is that in the CAT paper of this year, especially in the quant section, also in the LRDS section for that matter, do not rely on instinct and calculated guesswork and feel and vibe of the question to mark an option as the answer. Okay. Because sometimes answer can be as non-instinctive as this. Aryan, I don't know. I'm not going to make the prediction. But from my past experience, IIM Calcutta sets a paper in which proper processes are rewarded. How can we even think to do that? You think to solve the question mathematically, Sylvie. Thinking like that and like this requires instinct. Don't use an instinct. You know the methods. Follow the methods, follow the process, get to the correct answer, then mark the answer is what I'm saying. Don't use tips and tricks and guesswork. Some people do. So you will not believe how many people actually go to the paper to do that. Okay. Right. So that's all. That's all that I wanted to communicate through this class. Questions 3 and 4, okay, are simple questions. If you understood the concept of Bayes theorem, think and solve the question. Okay. I will be posting the answer values 24 hours from now. Tomorrow at 10 p.m., I will be posting the answers, or just the answers, not the solutions for questions 3 and 4. But before that, try those 2 questions out once. And if you can solve them correctly, then that means that you understand probability. Take it from me, if you can solve after listening to this class, if you can solve questions 3 and 4 correctly, you understand probability, and that is a topic that you can add to your repertoire, that you can target in the CAT paper despite not having practiced probability at all. Okay. Karan, I am not sure. We will communicate the schedule for the next class. In fact, I will not give you 24 hours. I will wait for this video to be uploaded on YouTube, and after that, I'll give you 24 hours from there. Okay. No animation. Not correct. Okay. Right. So I hope you had fun in this class. You had at least half as much fun as I had in creating these questions. By the way, thanks to Veritasium. Veritasium is a YouTube channel for question number 1. If you guys are not following Veritasium, please follow. It's a very nice channel. Instead of watching, say brain rot videos, I recommend that people should follow channels like Veritasium on YouTube and watch very informative content and very thought-provoking content that channels like Veritasium posts. Right, Ramit, excellent. Yes, Aviral, absolutely right. Vsauce new version, absolutely, there are multiple. I just want to give a shout out to Veritasium through this because he gave me the question with which I can make my point very well, this question. All right, guys, thank you and have a good night. Hope you had fun. Take care and good night.